In this video, I will go over a test that I just gave, and it was a test about geometric relationships, which included angle pairs. So we will talk about things like linear pairs, corresponding angles, vertical angles, alternate interior angles, that type of thing. We also talked about parallelograms and specifically rectangles and some of the equations that we could come up with. We also talked about midpoints and bisectors. So let's jump right in. For problem number 1, we have two angles that are congruent and also complementary. What are their measures? Alright, so complementary means that they have to add up to 90. So we have to have something plus something that equals 90. But they also have to be congruent. So congruent means they have to be the same. So that means if I take 90 and I divide by 2, then I should get two equal halves. So this would be, so if I do 45 plus 45, that should equal 90. And again, I got the 45 by taking 90 and dividing by 2. Alright, that is how I knew, whoops, hold on. That is how I knew that that would work. Okay, so anyway, 45 and 45. They are complementary because they add up to 90, and they are congruent because they are the same. Alright, in problem number 2, angle TRS and what form a linear pair? So first of all, angle TRS is this angle right here, TRS. And maybe I'll just color it in a little bit just to make it more obvious what we're talking about. So this is angle TRS. So we need to make a linear pair, so that's going to be a straight line. So if I take this angle right here, okay, that I'm coloring in blue, then it makes this nice straight line. So this blue angle is the answer, and this is angle QRT, or angle TRQ, which is answer B. Alright, number 3. Angle TRS and what are complementary? Alright, remember complementary means they add up to 90. So they have to add up to 90 degrees. TRS is again this angle right here, TRS, which again I'm going to just go ahead and color in yellow just to make it just extra clear that this is the angle that we're talking about. Alright, we need another angle that would make 90 degrees if put side by side. And I'll use blue again. I can see that this blue angle together with the original angle makes 90 degrees. Alright, I can tell because I see the box over here to the left, which means that this has to be 90 degrees over here to the right as well. So that is angle URT or angle TRU, true. So that's why the answer is A. Alright, the blue angle right there. Alright, number 4. These lines are parallel. No, are these lines parallel? Well, I'm looking at these angles that were given, the 89 and the 89. These are corresponding angles. Alright, corresponding angles that are angles that are in the same position on each x. You know, so I see an x right here, and I see another x over here. So the 89 is lower right and lower right. So those are corresponding angles, and if the lines are parallel, corresponding angles should be congruent. And they are congruent, so that means the lines must be parallel. So now I'm just looking for the answer that says what I just said. The answer was yes, they are parallel. So right away I know it's not going to be A or B. But they are parallel because these are corresponding angles, and they are congruent. So that's why the answer is D. Alright, number 5. We're naming things. So we want vertical angles. Okay, so angle 1 and angle 3 are what you call vertical angles. So angle 1 and angle 3. Alright, angle 2 and angle what are alternate exterior angles? Well, that would be angles like 2 and 7. Alright, they're outside of the lines and they're on opposite sides. So 2 and 7 are alternate exterior. Soak that in while I erase. Alright, now angle 3 and what are alternate interior? Well, that's like angle 3 and angle 8. These are alternate interior angles. Alright, angle 4 and angle what are corresponding angles? Oh, we just talked about that. Corresponding angles that are angles that are in the same position on each x. So angle 4 is in the lower left, and I see angle 7 here in the lower left. So these are corresponding, 4 and 7. Now angle 5 and angle what are consecutive interior? Angle 5 and angle 3. Alright, these are consecutive interior angles. Angle 5 and angle 3. Okay, number 6. Up. Oh, we're still using this diagram. Up here, so not so fast. Alright, in the diagram above, angle 4 must be congruent to which of the following angles? Circle all that apply. Okay, so let's just mark all of the angles that angle 4 will be congruent with. So there's angle 4. Angle 2 is a vertical angle, so those are going to be congruent. Angle 5 is alternate interior, so those should be congruent. And then angle 7 is now a vertical angle with angle 5, so those should be congruent. And that's it. So all 4 of these yellow angles should be congruent. So angle 4 should be congruent to angle 2, 5, and 7. Okay, so alright, I see 2 and 7, and 5 is not on the list, so there's nothing to circle for that. But 2, 5, and 7, so 2 and 7. Alright, find the value of x, then find the measures of angle 1, 2, and 3. We are given expressions for angle 1 and angle 2. Alright, angle 1 and angle 2 are consecutive interior angles. These are not necessarily congruent when the lines are parallel. These are supplementary. They have to be supplementary. So I'm not going to set these equal to each other. That's for like alternate interior angles or vertical angles. I'm going to make them add up to 180, supplementary. So I'm going to do 8x minus 2 plus 2x plus 22 is equal to 180. 8x and 2x make 10x. Negative 2 and positive 22 make 20. If I subtract 20, whoops, that should have been a 0. If I subtract 20 from both sides, I'm going to get 10x is equal to 160. Then if I divide both sides by 10, I'm going to get x equals 16. So now I have x equals 16. If I want to find the measure of angle 1, I can use the expression that I was given for the measure of angle 1. Okay, so the measure of angle 1 is equal to 8x minus 2. So that will be 8 times 16 minus 2. Whoops. So that's 126. Okay, now if I want to find the measure of angle 2, I could substitute 16 in right here, or I could subtract from 180 because I already know that these are supplementary. They have to add up to 180. So the measure of angle 2 should equal 180 minus 126. So that's 54. Now, the measure of angle 3, well, angle 3 and angle 1 are corresponding angles. See how they are in the same position on each x? So angle 1 and angle 3 should be congruent. So I don't have to do any math. I just know that angle 1 and angle 3 should be the same. So this should be 126. Alright, number 8. Find x. Okay, same type of thing. Angle 1 and angle 3 are right here. Boom, boom. These are vertical angles, and vertical angles are always congruent. So their measures should be equal. So I'm going to set them equal to each other. So 7x minus 27 is equal to 2x plus 18. I like to put the bigger x value in front. That's why I wrote it this way. You should get the same answer either way. So we need to bring these x's together. So I'm going to subtract the 2x, and that will give me 5x minus 27 is equal to 18. And then we would add the 27 to both sides. So that will give me 5x is equal to, so that's going to be 15. And so that's going to be 45. And then if we divide both sides by 5, that's going to give me 9. So x is 9. So if I want to find the measure of angle 1, I can use the expression that they gave me. So if I want to find the measure of angle 1, that's going to be 2x plus 18. So that's going to be 2 times 9 plus 18. That's just 18 plus 18, so that's going to be 36. So the measure of angle 1 is going to be 36. Angle 1 and angle 3 are congruent, so I can immediately jump down and put 36 for angle 3. Now, notice that angle 1 and angle 2 are a linear pair. See how they form a straight line together? So they are supplementary. So I should be able to get angle 2 by doing 180 minus the measure of angle 1. Okay, so if I do 180 minus 36, that's 144. Okay, and then angle 2 and angle 4 are vertical angles, so they should be the same. Alright, number 9. Okay, we have to draw our own picture. Segment BC bisects angle EBA. I recommend drawing the second thing first. Okay, so let's draw angle EBA. So here we go. Angle EBA might be something like this. All right, EBA. And then segment BC bisects. All right, bisects means to cut exactly in half. All right, so segment BC has to go from B to C. So I'm going to put point C out here. So this would be segment BC. Okay, now these two angles should be congruent because BC cuts EBA in half, two equal halves. We are told that angle EBC is 62. So EBC is the first angle right here. It is 62 degrees. That means that angle CBA must also be 62 degrees because these are the same. That also means that if they were to ask me for the measure of angle EBA, you know, the big angle, that would just be 62 plus 62. So that would be 124 if they asked me for that degrees. Okay, so let's go back and look and see what they actually ask us for. What's the measure of angle EBA? Well, EBA is the big angle that I just marked here in green. So we just decided that that should be 124 degrees. What's the measure of angle CBA? All right, CBA is the one that I just did in purple. All right, that is 62 degrees. Okay, for number 10, they were nice enough to give us a picture. They're telling us that G is the midpoint, which means that these two segments are congruent to each other. Let's see, KG is 2x plus 28. So I'm going to color code this a little bit. So here's KG. All right, so I'm just going to mark that with this little arc right here that has the same color to it. But then KL is 12x plus 12. And I'm going to mark KL as well. All right, but I'm going to mark that in green to make it really clear. So I've got the red segment and I've got the green segment. Are they the same? Clearly not. All right, the green one is twice as big as the red one. So I'm not going to set them equal to each other. That would be a common mistake. Instead, we're going to use the common sense idea that two halves make a whole. All right, so 2 times the half should equal the whole. So which one of these colors is the half and which one is the whole? Obviously the red part, the KG, is the half. So 2 times the red one, all right, 2 times 2x plus 28 should equal the whole, the green one, the KL, the 12x plus 12. So we're just going to solve this. We can do the distributive property, which will give us 4x plus 56 is equal to 12x plus 12. And then we need to get the x's together. I like to keep the x's positive, so I'm going to subtract the smaller one like this. So then that will be 56 is equal to 8x plus 12. And then we need to subtract 12 from both sides. So that's going to make 44. So then we have 44 is equal to 8x. And of course then we will divide both sides by 8. And 44 divided by 8 is 5.5. Okay, so x is 5.5. Number 11. So they have given me this picture, and they're telling me that ABCD is a rectangle. That is very, very important. So really focus on the fact that this is a rectangle. Because when I have a rectangle, there are a couple things that I know. First of all, a rectangle has 4 90-degree angles. So all 4 angles are 90 degrees. I'm going to need that later. But also, a rectangle has symmetry. So if I draw a line like this, it's going to be the same above and below that line. Or if I draw a line like this, it's going to be the same to the left and to the right. All right, I'm going to use that symmetry. So just keep that in mind. The symmetry and 90-degree angles make it really easy to solve a rectangle. So for example, so they gave me this 58 right here, or they gave me some other things too, but I'm going to start with this angle. So if I draw this line of symmetry, I see the 58 below, so that's going to be the same above. So this angle right here will also be 58 because of this symmetry. Now, if I draw the other line of symmetry instead, alright, so this is a line of symmetry. So that means that the image on the left will be reflected on the right. So both of these angles should appear here and here because of symmetry. Alright, so just from symmetry alone, I got these 3 angles. Now I can get the rest of the angles using the other property of a rectangle, which is that each of these angles has to add up to 90 degrees. So for example, when I look at this angle right here, that I just colored in yellow, this has to be a 90-degree angle. And they have given me one part of the angle, so I should be able to find the other part by subtracting from 90. So if I do 90 minus 58, so that's going to be 32. So they add up to 90, so it has to be 32. And it's going to be the same situation in every corner. So whether you think of the rest of this as symmetry, where it's everything is being reflected, or if you think to yourself they all have to add up to 90, so it has to be 32 all the way around. Either way, we will get the rest of these angles. So we should now be able to answer any question they ask us about angles. So let's see, what is the measure of angle ACB? Let me get ready by erasing that yellow. Okay, angle ACB is this angle right here, from A to C to B. Well, that is the 32 that's sitting right there in the corner. All right, what about ABD? Okay, A to B to D. All right, see this 58 in the corner? So 58. Okay, what about angle CDA? CDA. Well, that's 90 degrees. I don't really have to add these up. That's just the entire angle of the rectangle. So we know that has to be 90 degrees. So that's it for the angle questions. So now I'm being asked for the length of a segment. So I think I will actually erase all these little angle marks so I can just focus on the segments now. So they told me that AC is 34. Okay, so I think I'll just use light colors. So this AC, that is 34. All right, keep that in mind. Now, AB is 18. So this is AB over here, and that is 18. Okay, maybe I'll make some attempt. So AB is 18, so I can pretty easily just go ahead and put that down. The AC is a little trickier to label because of all the lines that are in the way, but I can maybe do something like this. Alright, and put this 34. Alright, to show that this whole thing is 34. Now, they are asking me for BE. Okay, interesting. So they're asking me for this little piece right here. Well, I'm going to have to erase the 34 that I put. So the first thing you need to understand is, remember the symmetry we were talking about? So in a rectangle, the diagonals are going to be congruent. So this red diagonal is going to be the same length as this purple diagonal. Alright, the red and purple are equal. So if the red is 34, that means the purple is also 34. Okay, so this has to be 34 because it has to be the same length as this one, which is 34. But then they asked me for BE. So BE is just this little piece right here. Well, that's half of the purple. So if the purple is 34, then BE has to be half of that, which should be 17. Alright, so that's it. BE is 17. Alright, number 12. Find the values of x and y. Alright, so this is a parallelogram. It's not a rectangle. But there are some things that we know. Opposite angles are congruent. So these two angles are opposite angles. They must be congruent. So I can just make this little equation that goes 5x plus 14 should equal 124. Let's go ahead and subtract 14 from both sides. So that's going to give me 5x is equal to 110. Next, I would divide both sides by 5. And so that will leave me with x equals, and I want to say 22, but I'm going to check it. Okay. So x is 22. All right, now it's time to find y. Well, so I'm going to switch my attention now. Let me erase the yellow that I put before. So I need to find y. Well, look at these two. These two should be supplementary. These are consecutive angles, and inside a parallelogram we know that consecutive angles are supplementary. They have to add up to 180. So the equation here should be 4y plus 124 is equal to 180. Subtract 124 from both sides, so that'll be 4y is equal to 56. And then we're going to divide both sides by 4. So that's 14. And that's it. Alright, so here we have a parallelogram. Okay, they're giving me AG. Let's color coordinate as we go. So they're giving me AG, which is this. I'm going to make that yellow. And they're giving me LA, alright, which is this. Alright, which I will color as blue for easy reference. Should these be the same? I think not. So we are not going to set these equal to each other. That would be a common mistake. How should they be related? Clearly the yellow one is half of the blue one. So this is when we use our common sense that tells us that 2 halves should make a whole. Okay, so remember the half is the yellow piece, which I have color coded for easy reference. So 4x plus 16. The whole is the blue, which is 12x minus 28. A little distributive property tells us that 8x plus 32 is equal to 12x minus 28. We need to get these x's together. I like to keep the x's positive, so I'm going to subtract the small one. Alright, so that is going to give me 32 is equal to 4x minus 28. So then I'm going to add 28 to both sides. So that's 60. Better pick up over here. So now I have 60 is equal to 4x. So of course I will divide both sides by 4, and that's going to give me x is equal to 15. So x is equal to 15. Now I'm supposed to find AG. I have an expression for AG. Okay, so AG is 4x plus 16. So that's 4 times 15 plus 16. Okay, I think I'm going to use my calculator. Help me out. So 4 times 15 plus 16. Well, that should be 60. Should be 76. So that's AG is 76. Next, they want LA. But remember, the yellow and the blue, AG and LA. LA is double AG. The blue is double the yellow. So if I just take this and double it, I should have LA. So if I just take my 76 and do times 2, 152. Okay, that should be it. All right, GL. GL is right here. GL is this. GL is a half. So GL and AG should be the same. So AG is 76, so GL should also be 76. They're both halves, so they should equal each other. Half equals half. Alright, so if that's 76, then this should also be 76. Alright, that is it for number 13. Okay, number 14. This plot of land is in the shape of a parallelogram. Find the value of m, then find the amount of fencing that would be required to surround all 4 sides of land, the perimeter of the parallelogram. Okay, so I remember getting a lot of questions about a problem like this on the review that we had, because students want to know, how do I make an equation with these 3 sides? What do I do with the 3rd side? Well, at first you don't do anything. At first you just recognize the fact that this side and this side should be equal to each other because they're opposite sides of a parallelogram. So at first I'm not going to do anything with the third side. So I'm just going to do 6m minus 20 equals 2m plus 8. If we subtract 2m from both sides, that will give us 4m minus 20 is equal to 8. And then if I add 20 to both sides, so that will be 4m is equal to 28. Then if I divide both sides by 4, that's going to give me m is equal to 7. So that's one of the things we're supposed to find. Alright, now I'm going to start plugging this into the different expressions. So for example, if I plug in 7 right here, well, that's 4 times 7, so that's 28. So that means this side right here is 28. Which automatically, so by the way, that's a reason to have 4m. You know, if you were feeling like they just put that in there to trick us. Nope, we needed it so we could find this side afterwards. Anyway, this is a parallelogram, so opposite sides are congruent. So this side over here is also going to be 28. Meanwhile, if I put 7 in for m right here, that's 2 times 7, that's 14. Alright, plus 8, so that's going to be 22. And if that's 22, then this side will be 22. No need to plug in. Okay, so then that means that the perimeter will be the sum of all 4 of these. So we should be doing 22 plus 22 plus 28 plus 28. Alright, but that's going to be, let's see, 22 plus 28 is 50. So this should be 100. So the perimeter should be 100. Alright, here we have a review problem from the previous unit where we will use Sohcahtoa, sine, cosine, and tangent. So a hot air balloon begins to float away from the ground, but a rope is still attached as shown. The rope is 200 feet long. So that tells me that this is 200 right here. It's at an angle of elevation of 11 degrees. So that's going to be 11 degrees will be right here. How high above the ground is the balloon? So that's going to be x right there. So this is a right triangle, and it is helpful to label all of the sides. So for example, the rope is the hypotenuse because it's across from the 90-degree angle. If I draw an arrow across from the angle like this, that should be pointing at the opposite side, which means the other side is adjacent, but we're not going to wind up needing that. Now, so we often will say the following, Sohcahtoa. Sohcahtoa. But this is just to remind us that sine is opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. But in this problem, we are looking for the opposite side, and we are given the hypotenuse. So this problem involves opposite and hypotenuse, and the only one of these 3 trig functions that involves opposite and hypotenuse is the first one, the O and H, that's opposite and hypotenuse. This is the sine function. So the equation goes like this. Sine, and then goes the angle, is equal to opposite over hypotenuse. So in this case, it will be x over 200. And then To solve a problem like this, you multiply both sides by 200. That way these will cancel each other out. Alright, so what goes in your calculator is 200 sine 11, because that should equal x. So if we do 200 sine 11, we get 38.162. Got to round up because of the 7. 38.162. feet above the ground. Alright, now we have a bonus problem. So let's see what we can do with this. This is a rectangle, so don't forget about symmetry, which should make this somewhat easier to do. Let's fill in everything we can. Because of symmetry, well, actually, because this is vertical angles, this is 54, so this will be 54. I see the 12 length over here, so this is going to be 12 over here. I'm just filling in all the angles that I can. I see that the 54 and the E, alright, this is a linear pair right here. See how they make a straight line? So they have to add up to 180. So if I do 180 minus 54, that should give it to me. Alright, I don't know if I'm even going to need this. 126. But you know what? I like to find these things just in case. Alright, so this is 126 and this is 126. Okay. What are they actually asking us to find? Okay, so we need to find the area of the rectangle. Okay, so in order to find the area of the rectangle, we are going to need to find, for example, BC. The area of a rectangle is like base times height, sort of like length times width. So we need to find one of these. But in order to find the length of the bottom, we need some more of these angles. Okay, we need to find some more angles. So this is what we need to do. Because of symmetry, we know that these two angles, for example, are going to be the same. So we know that all of the angles inside of a triangle add up to 180. So far we have 126 degrees right here. Let's see what happens if we subtract that from 180. Alright, so we do 180 minus 126. That's 54. Alright, now be careful. So I've got 54 degrees, but I've got two angles. So this 54 degrees has to be shared equally. Alright, it's a rectangle, it has symmetry, so it has to be shared equally between these two. So that's going to be 27, because if I divide by 2, I get 27. So that means this angle is going to be 27, and this angle right here is also going to be 27. Now you could double check that if you add up all three of these purple numbers, you're going to get 180, as you should. Okay, now I'm going to use this information to find BC. Alright, this is my target. But look, this is how I'm going to do it. I'm going to copy this triangle right here. And I'm going to bring it down below. Okay, so see that yellow triangle? Keep your eye on it. I'm just going to duplicate it real quick down here. Okay, so see the A up here? So this is angle A, and this is angle C, and this is angle B. It's a rectangle, so I know this is 90 degrees. Now this side down here at the bottom is what I'm trying to find, remember? Okay, so I'm going to call that x. Now, the 12. They gave me that AB was 12. So there I've got 12 right there. Now here's the thing that's the most important that we just found that we needed. This angle right here, that 27. Can you see that the angle, the 27 degrees is going to be right here in my new picture. Okay, so there's my 27 degrees. So I can solve this problem using Sohcahtoa, sine, cosine, or tangent. So that's what I'm going to do. I'm going to do Sohcahtoa. Now, I know that this is the hypotenuse, and if I draw an arrow away from the angle, that's going to always point at the opposite leg. So this is opposite, which means that this is adjacent. But the hypotenuse isn't doing anything. There's no number here, there's no variable, so ignore that. So all we really have is opposite and adjacent. So which function is that? Alright, that's this one. See the opposite and the adjacent right in there. So this is tangent. So we're going to set up the equation. Tangent of the angle, so tangent of 27 is equal to opposite over adjacent. So in this case, that'll be 12 over x. And then when the variable is in the denominator, this is when you swap these. So this is going to give me x is equal to 12 over tangent 27. So I can just put that in my calculator. So 12 over tangent 27. So 23.551. Alright, so x is 23.551. So remember what I just found. X is the length of BC. So I'm going to go all the way back and put this back into my picture. Okay, so I just found x, which goes right here. So this side is 23.551. Now I can find the area of this rectangle, because the area is base times height, length times width. So it's going to be 23.551 times 12. Okay, so the area should be 23.551 times 12. So 282.612. Okay, did they give us units? They didn't give us units. So if they had, they would be squared. So maybe I'll just say units squared. Alright, that's the bonus. That was quite a problem. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.